Hi everyone, in today's lesson we're going to talk about trig derivatives. The first two definitions are the derivative of sine is cosine and the derivative of cosine is negative sine. Now I could prove these two for you, but it would be using the difference quotient and we would have to take the limit as h approaches 0 and this process would just take too long. So just accept my definition that the derivative of sine is cosine and the derivative of cosine is negative sine. Now, we're going to use these definitions to find the derivatives of, say, negative sine. So this is that constant multiple rule, such that if I'm wanting to take the derivative, say, f of x, of negative 1 times sine of x, I technically can take the derivative of sine of x and then multiply it by negative 1. So f prime is simply, if the derivative of sine is cosine, then it's just going to be, so the derivative of sine is cosine, and all we're doing is bringing down this negative 1. So if you want to write it simpler, f prime is negative cosine of x. Okay? And then what if I'm asking you to take the derivative of negative cos? Same concept. You're just going to rewrite it as y equals negative 1 times cosine of x. And we know that the derivative of cosine from up here is negative sine. So we can put negative sine of x. But then we're multiplying it by this negative 1. And just be careful. Make sure, since it's in y equals, the derivative is dy dx. So make sure you're writing it as the correct form, or in the correct form rather. So dy dx, if you multiply the two negatives together, you just get positive sine x. So again, for notation, if it's given to you as f of x, you could write the derivative as f prime. If it's given to you in y equals, we write the derivative as dy over dx. Now, these four things might get confusing, and it might seem hard to remember them. So there's a little way or a little trick that we could use to memorize the derivatives of sine and cosine. So the trick is simply this: sine, cos, negative sine, negative cos. So we move from left to right. So if we want to find the derivative of, say, sine, we just look to the right. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And the derivative of negative cosine just goes all the way back to the front, which is sine. And that's it. That is how we find the derivatives in a quicker fashion. So let's use the definitions above to prove what the following four other trig identities would be. So we need to use the quotient rule for this. Why? Well, if we rewrite tangent of x, we know that tangent of x is sine x over cosine x. So now we have a fraction. If we have a fraction, we have to use the quotient rule, where the top is my high and the bottom is my low. So remember, f prime is low times d high, the derivative of the high. So the derivative of sine, if we look over here, is cosine. So low d high minus high, which is sine x, and then d low. So the derivative of cos is negative sine. So times negative sine of x all over low squared. So cosine of theta, or cosine of x, this whole thing squared. So if we simplify this, cosine times cosine is nothing other than cosine squared. So we want to get into the habit of writing it as cosine squared x. That's exactly the same thing as writing it as cosine of x squared, but sometimes it's just the abbreviated way we put the squared on the inside. So now we're going to do negative sine times negative sine, which is a positive sine squared, all over, and we can abbreviate this one to be cosine squared of x. Now, I don't know if you remember the identity or not, but you did learn in pre-calc and algebra 2 that cosine squared plus sine squared is equivalent to 1. So if we know that, f prime of x is 1 over cosine squared. And furthermore, we know that cosine squared is in fact, or 1 over cosine is in fact secant. So f prime is secant squared x. So the derivative of tangent is nothing other than secant squared. All right, let's prove secant. So we know that secant is the same thing as saying 1 over cos. So again, we now have a fraction where 1 is my high, cos is my low. So if I want to find f prime of x, it's low, d high. Well, the derivative of 1 is 0. So low d high minus high, 1. And the derivative of cosine is nothing other, if we look over here, negative sine. So 1 times negative sine of x all over cosine squared, low squared. And now we can actually simplify. Cosine times 0 is nothing other than 0. So f prime of x is 0, which actually I'm not even going to write. And a negative times a negative is a positive. So this actually just becomes positive sine x over cosine squared x. And we actually can simplify that a little bit more if we make it sine x over cos x times the extra cos x on the bottom, right? I can do that when I multiply fractions. Bottom times bottom equals this. Tops times tops equals that. So I could technically put the 1 right here. And we know that sine of x over cosine of x is the same thing as saying tangent of x. And 1 over cos x is the same thing as saying secant. So the derivative, f prime, is tangent x times secant x. So the derivative of secant is tan secant. Sometimes we say secant tan. The order doesn't matter because multiplication is commutative. All right, let's do the next one. So if I want to find the derivative of cotangent, first we need to write it. We know that cotangent is cosine of x over sine x. And we know that the cosine is my high and the sine is my low. So to find the derivative, f prime of x, it's low. D high, the derivative of cosine is negative sine, minus high. D low, the derivative of sine is cosine, all over low squared. And we can simplify by multiplying. Sine times negative sine is negative sine squared, minus cos times cos is just cos squared, over sine squared. And something interesting that I can do is it's similar to the Pythagorean identity that I had before, except it doesn't have a plus sign. But I can make it a plus sign if I just take out a GCF of negative 1 on top. So if I do that, I'm left with sine squared x plus cosine squared x all over sine squared. So now I have what I need. This sine squared theta plus cosine squared theta, we know from our Pythagorean identities that this whole thing is going to equal 1. So my top for my derivative is simply negative 1 over sine squared. And we know that 1 over sine is cosecant. So my derivative is nothing other than negative cosecant squared x. So the derivative of cotangent is negative cosecant squared. All right, I'd actually like you to try this last one on your own. So starting with cosecant of x, I'd like you to find what the derivative would be. And then hit resume when you're ready for the answer. Okay, here's the work. So take a look at a couple things here. The first thing was, here's my quotient rule, And I was left with negative cosine over sine squared. So I did what I did in the problem before. I broke up the sine squared into sine times sine on the bottom. So I have a negative cos over sine, which is a negative cotangent, and 1 over sine is cosecant. So I just wanted to prove those trig derivatives for you. I'm not asking you to prove them, but I'm going to ask you to use them. So that brings me to the next page. So here is the textbook definitions of what we just did. So the notation here is something that we want to look out for. d dx means take the derivative of sine of u. So the derivative of sine of u is cosine of u du dx. What that means is we always have to remember to take the derivative of the inside. So with all the problems I did in the beginning, the u value was just, or x value was just x. So notice how in these problems there are other things inside the parentheses. So this is kind of where the chain rule is going to happen. So if we're taking the derivative of sine, we know it's cosine, and then times the derivative of the inside. That's what du dx means. See this u on the inside? So I always like to say du dx means derivative of the inside. And as we do some problems, it'll make some more sense. So you may also want to write on top of your paper sine, cos, negative cos. It at least helps with these first two derivatives and positives and negatives. So let's talk through a couple of examples. So problem number 1 says, what is the derivative, or find the derivative of negative sine of 3x? So if we're at negative sine and we want to find the derivative, it's simply negative cos. So we're going to start by just saying f prime of x is negative cos of whatever's in the inside. Then we have to take the derivative of the inside. So the derivative of the inside, the derivative of 3x, is just 3. And if we wanted to write it nice and pretty, we would rearrange it as negative 3 cos 3x. And that would be my derivative. So just a couple of notes. This is the du dx. That is the derivative of the inside function. All right. So it'll get better as we do some more problems. So let's try another one. So I have f of x equals 2 cos 4x, negative 4x. So we could first start by writing it as f of x equals 2 times cos of negative 4x. So if I want to take the derivative, it's just going to be 2 times the derivative of whatever this is. So we know from here that the derivative of cosine is negative sine. So we're going to times this by negative sine of negative 4x. Remember, we repeat the inside. Whatever's in the inside stays in the inside. Then we have to take the derivative of the inside. So the derivative of negative 4x is just negative 4. So this negative 4 is the du dx, the derivative of the inside of the parentheses. So if we simplify things, we've got 2, negative 1, and negative 4. A negative times a negative is a positive, and 2 times 4 is 8. So my final answer, f prime of x, is equal to 8 sine of negative 4x. Okay, let's look at number 3. So number 3 says, find the derivative of negative cosecant of 2x plus 3. So we have to go over here. The derivative of cosecant is negative cosecant cotangent. But notice, I want to take the derivative of negative. So we're going to do the same thing that we did in all the other problems. So we're going to first rewrite it as f of x equals negative 1 times cosecant of 2x plus 3. And we're going to take the derivative of this piece. So f prime is going to be negative 1 times, now the derivative of cosecant is negative cosecant cotangent. So negative cosecant of the same stuff times cotangent of the same stuff, right? But then du over dx means take the derivative of the inside. So the derivative of this 2x plus 3 is just 2. So this 2 is your du over dx, the derivative of the inside. So if I want to simplify this just a little bit, the derivative negative times a negative is a positive, and then there's a 2 hanging out in front. So we can rearrange it, and we'll say 2 cosecant of 2x plus 3 cotangent of 2x plus 3. And this is your final answer. All right, why don't you guys try number 4 on your own and then hit resume when you're ready for the answer. Okay, so the first thing is to rewrite f of x as 1/4 times secant of negative 5x minus 1. And the derivative of secant, if we look up here, is secant tan times the derivative of the inside. So if I'm taking this derivative, we're going to say, okay, the derivative of secant is secant negative 5x minus 1 times tan negative 5x minus 1. Don't forget, times the derivative of the inside, so times negative 5. And don't forget to bring down your 1/4. So if we put this all together, 1/4 times negative 5 is negative 5/4 secant negative 5x minus 1 and tangent negative 5x minus 1. Sorry, that's a little small. I just kind of ran out of room there. But that is your, let's see if I can move it a little bit. That is your final derivative. So this would be times negative 5 if I try to move that around a little bit. So feel free to pause the video if you need to and copy down the correct answer. All right, a couple more and we're done. All right, problem number 5 and problem number 6. So we have a tangent squared here. And if you notice, you're only taking the derivatives of sine, cos, tan. Cosecant, secant, cotangent. So there's nothing that says, how do I take the derivative of just regular tan? So we have to understand that if I'm writing it as squared, that it's the same thing as saying tangent of 7x to the 4th minus x squared, this whole thing squared, right? Kind of like before when we did cos squared x, and we know that that's the same thing as saying cosine of x, that whole thing squared. So by changing it to this squared on the outside, it will allow us to use the chain rule. So the chain rule says we take the exponent, we bring it in front, right? So the 2, then we keep the inside, tan 7x to the 4th minus x squared, and we decrease the power by 1, and then we take the derivative of the inside. But the derivative of this inside is going to be another chain rule, because the derivative of tangent is secant squared times the derivative of the inside. So if I'm taking the derivative of tangent, we're saying it's secant squared, 7x to the 4th minus x squared, then times the derivative of the inside. So the inside in this particular case now is this. The derivative of that inside is 28x to the 3rd minus 2x, all in parentheses. So that, f prime of x, is my derivative. So let me just explain that one more time. We're taking the 2, bringing it in front, keeping all of this, and then dropping the power down by 1. Then that's it. Chain rule says we have to take the derivative of the inside. Well, the derivative of tangent is secant squared, so secant squared of the same inside. Then times du dx, which means the derivative of this inside, which is 28x to the 3rd minus 2x. All right, why don't you guys try number 6 and then hit resume when you're ready for the answer. All right, I'm going to put the work for 6 down here. So the first thing you needed to do with 6 is rewrite it as cotangent of 4x plus 5, this whole thing squared. So then when you take the derivative, f prime of x, you're taking the exponent, dropping it in front. So 2 cotangent of 4x plus 5, now to the first power, then times the derivative of the inside. So the derivative of cotangent, if we look over here, is negative cosecant squared. So times negative cosecant squared of 4x plus 5, times, don't forget, the du over dx, times the derivative of the inside. And 4x plus 5 is in the inside, so that derivative is simply 4. So this one we can actually simplify a little bit, right? 2, -1, and 4. That's going to multiply to -8. So f prime of x is -8 times cotangent of 4x plus 5 times cosecant squared of 4x plus 5. And that is your simplified answer. All right, I know that was a lot for today, but please make sure you're taking down good notes, this especially. And if you have any questions, jot them down and ask us in class tomorrow. All right, have a good night.